So zoom out here. So what we're going to do then is we'll go ahead and start it up. I believe that covers all the components as far as what we're taking off. And this not only tunes for maximum efficiency, but this is also tuning for getting a really nice clean wave and eliminating all ringing. And I'm going to show two power modes. Most everybody's going to probably run the lower power mode, and it will be base untied, but you do have to start the circuit and get it to voltage with base tied. And you can use either mode that you want. I would probably recommend putting a high-low switch. So you basically start it in high and run it to your 12 volts, and then you can flick to low, which would be removing the base tie. And I imagine that's where most people are going to want, because this is the max efficiency. Okay, so now finally we'll run it up. And again, I've tuned this for 12 volts like everything else. And go to 12 here. Looking for 12 volts, 780 milliamps, somewhere in there. And I've got a scope. Let me make sure my scope's hooked up. I'll show you guys that too. Okay. There we go. I'm going to readjust here. Make sure I'm where I want to be. There we go. 12 volts, 780 milliamps. There's a wave shape at the input, at the socket. You can see very nice wave. And what I've done is I've taken out the ringing. Let me drop the voltage real quick. See, I took out that ringing. It's why this is 11.5 volts. Okay, and there's 12 volts. So it's tuned for 12 volts. So I took that ringing out, and then on the top side, anybody remembers my 1.1? We saw a little ringing up there. That was from that little inductor we pulled out. So we get a very nice clean wave in here. And this is taken across the input, right where the socket would be, across the load. Okay. Now let me get this again at the right point to make sure I'm at my same numbers. 12 volts, 780. Okay. And then I'm set on X10 here, times 10, you can see, so that's 2890 or 2900 lux. And again, yeah, my mark to try to hit, just to, there we go. That's a little closer there. You can see very touchy around, yeah, 2910, 2900. Not moving. 12 volts, 780 milliamps. Now, so this is high mode. Okay, pull the base. 12 volts, 500 milliamps. Nice wave still. Down to what? 2260. And so that's your two modes. Okay. And this is probably the mode everybody's going to run in. Flip it back to high. You know, you're right back to your same point, same wave. And I guess I should show too, to ensure that this is light. This is very bright. Okay. Even got the nice streaking on the camera, which I don't think has been seen before. And then in low mode, and there's your low mode. Okay. Nothing gets hot, everything runs cool. No ringing, no funky kicks. And yeah, okay, so I'll shut this off. Let's put this together here real quick. So, here's what I just showed. Okay, so then this up here was my adjustment, adding the 0.2 because the 1 microfarad threw out my numbers. So 2900 lumens, or lux, 12 volts, 780 milliamps is 9.36 watts. We're getting 752 lumens. That's 92% light output for 48.3 lumens per watt, okay, in the high mode. And then again, this is recalibrated for the daylights. Okay, if you remember my scribbles from before, daylights, okay, have a 0.156 calibration, whereas everything else averages to a 0.201. Okay, so this is accurate to within 0.5% or maybe 1% of the lumens you're getting. If I did not recalibrate, okay, for the daylights, and I continued using my non-calibrated, you know, from all the other bulbs, we would be assuming 583 lumens at 62.3 lumens per watt, which again would be well over the rated output on the bulb and darn near the lumens per watt of the bulb. And then in low light, in the lower light mode, we're at 12 volts, 500 milliamps, 6 watts, 2270 on lux, 354 lumens, so that's about 72% output, and we're getting a 59 lumens per watt. Okay, so we're basically then here. This is where you want to be. 72% output, 60 lumens per watt, and you know, and again, this is basically where they are at from the factory. You know, the daylight bulb is 65 lumens per watt. So I've been trying to get good lumens per watt at good lumens. This is still 350. Again, 72% output, 6 watts, 59 lumens per watt. And again, if we used our non-calibrated, if we were assuming that this is the same conversion factor for the daylights as everything else, we would be assuming we're getting 456 lumens here, and we would be assuming 76 lumens per watt. Again, that it's not 76 lumens per watt. I think that would be the highest number shown so far, but it's in fact 59. Okay, and this is accurate within 0.5%. This is accurate within 5%. Okay, so I prefer the calibrated. So you're getting 450 lumens in high, 350 lumens in low, 48 lumens per watt, 59 lumens per watt. If we figure then 6 watts at this output, you know, the corrected, then this total conversion, including the power required for the transformer, the transistor, the circuit, and running the bulbs, we're running 90.3% conversion efficiency. Okay, this is basically what this means is that in the low power mode, this will beat any inverter on the planet. Okay, inverters at best can get to 95% conversion efficiency, not including their own power to operate. Most of them run at 90% conversion efficiency plus their power to operate. Okay, we're getting the power to operate and the conversion for 90% at decent lumens. And I will point out too, then the stock bulb with the base removed at 11.8 volts, 580 milliamps, gives you 217 lumens, or set 31 lumens per watt, okay, at the corrected factor. So we are doubling the efficiency by doing these mods. So they're very important. And again, that's for the daylight. And I can show here too, because I had tweaked. I was at 57. I've gained 2 lumens per watt. I said I was beating around with that, and that's basically the last cap adjustments, doing the 1 microfarad and getting rid of that LC coil gave me the extra 2 lumens per watt there. So like I said, these numbers are very specific to the Utilitech bulbs and this Radio Shack transformer. Okay, and it's a patch or a fix for anybody that bought what I recommended there to get you in very viable range. So again, we're a couple lumens per watt higher than this by making my final tweaks, but I want to point that whereas daylight we're getting the 59, 57 here, okay, so it's 59 now with the finalized version. We would be 53, so around 54 or 55 lumens per watt if we did the warm white, okay, and you'd be down to yeah, you'd probably be down to 320 lumens or somewhere in that range. So that by, again, the same difference as it is untuned. The daylight's about, you know, 4 or 5 lumens per watt more efficient. So there it is, 60 lumens per watt. And then I'm going to go ahead and disconnect everything so that you can see a little better, since I said I would. Alright, so again, here's the circuit. So there's the 1 microfarad, and we have the 0.22 in parallel. There's the 0.047 across the bridge diode, the bridge rectifier. Right now I just have a wire lead stuck on my input, and I'm clipping my positive lead to the ferrite, and the ferrite makes no difference, doesn't matter, we're not in high enough frequency for that. And again, yeah, it's the 0.2 unbridged across. You can see the inductor's gone. Got a little wire soldered across right there. And then I left this tipped up, but this whole circuit can obviously slide, like I said, right back in the bulb. And you know, you can basically, you know, get this all hidden out, and if you want to put the bulb back together, it's up to you. So again, I just wanted to point those out because I thought they were, you know, fairly important. I wanted to try to get everybody some good viable numbers for that we're using the Radio Shack transformers and the Utilitech bulbs. So again, hope this helps. And again, I'm not wanting to post things. I just felt that this was important to get out, so that everybody that had purchased some of these things that I'd suggested can get to some real world usable efficiencies. Okay, and this is now very accurate confirmation that will beat any inverter on the planet. Thanks.